we are now looking at target 4.1. Our mastery learning objective says I can find the probability of the complement of an event by finding the probability of the event. All right, so we first have to look at what probability is. You've probably done something with probability before. So the probability is the likelihood of an event occurring. All right, so how likely it is something to happen. And the probability of an event, so for example, an event could be I have a bag of marbles and I pull a blue marble. The blue marble is the event. Even if there's red marbles, there's green marbles, right? So I'm specifically looking for the event that a blue marble gets pulled. So the probability of event is the number of outcomes for, that's supposed to be the event. I cannot spell today, ever, I guess. I'm going to try that again. For the event divided by the number of outcomes total. Okay, so the number of things that number of times that specific event could happen over the number of total things that could happen. Okay? Then we have what we call an impossible event. Okay, an impossible event has a probability of 0. So therefore, it will not happen. Probability of the sky being pink. Well, I guess during sunrises. Probability of the sky being green, right? The sky's not green, it's blue, right? Whatever. That has a probability of 0. A certain event is the probability, is something with a probability of 1. That's the highest probability it can go. Definitely going to happen. Probability that the sun rises tomorrow, right? It's definitely going to happen, no matter what, right? So that has a probability of 1. Alati, you've already seen me write it. Forgot I put it down here. This is read as probability of events. Okay, so you'll see this. It's asking for that probability. Okay, so that P is probability of the events. All right, if we look at example 1, you have 4 red, 6 black, 3 blue, 2 yellow, and 5 purple marbles. We're going to find all of these probabilities. One thing I forgot is the complement. Forgot to put that in our vocab, so let's add that. The complement, underline it or something so we know it is a vocab word, is the probability of it not happening. Okay, so the probability of the complement, if I ask for like the probability of the complement of rolling a 2 on a 6-sided die, right, I would find all of the things that aren't 2s and find that probability. So you can count, or the probability of an event A, not the complement of an event A, this little tick mark tells you that you're finding the complement. Oops. Equals 1 minus the probability of that event. Okay. All right, it's everything that's not it. So it's the whole probability of all the universe, which is 1, right? If it's certain to happen, minus the probability of that thing happening will give us the probability of it not happening. All right. Now let's look at example 1. You have 4 red, 6 black, 3 blue, 2 yellow, and 5 purple marbles. So over here, I'm going to put my total number of marbles. 4 plus 6 is 10, plus 3 is 13, plus 2 is 15, plus 5 is 20. So the probability of a purple marble, well, I have 5 purple marbles over 20 total marbles, right? So the probability is 1/4. Nice and easy. The probability of a black, well, I have 6 black marbles over 20 total marbles. So my probability is 3/10. Ooh, now I can choose black or blue. Well, if I have 6 black and 5 blue, oh, and 3 blue, sorry, that was purple. If I have 6 black and 3 blue, then between my black and blue, there's 9 out of 20, and that does not reduce. All right, so I can choose black or blue. There's 9 choices I have out of the 20 total choices. Same thing with red or yellow. I have 6 out of 20 choices. 3 out of 20. 3 out of 10. Probably like orange. If I look, 4 red, 6 black, 3 blue, 2 yellow, 5 purple, I don't have any orange marbles. So the probability is 0 out of 20, or it's that impossible event, right? It's a probability of 0. Probability of reaching in and pulling out a red, a black, a blue, a yellow, or a purple. Black. Oh, well, I'm definitely going to do that. If I can pull out any of those colors, 20 of my marbles fit in those colors out of 20. There's my certain. I am certain to pull out at least one of those colors because that's all I have in my bag of marbles. Now here we have not red. Well, if I have 4 red, and the probability of not red equals 1 minus the probability of red, which is 4 out of 20, which equals 16 out of 20, or 4/5. All right, so I am just subtracting that probability. I could also add up everything that's not red. 6 plus 3 plus 2 plus 5 is 16. Complement of blue is asking the same type of thing, right? This not and this complement of are the same question. Right? So it's 1 minus, I have 3 out of 20 blues, which is 17 out of 20, and that does not reduce. All right, let's go ahead and look at the next page. You have a fair 6-sided die. So if I have a 6-sided die, my options are a 1, a 2, 3, 4, 5, or 6. So I have 1, 2, 3, 4, 5, 6 options. So the probability of a 2. There is 1 2 out of 6 total options. The most common answer is what is the probability of 2 on this type of question is 2 out of 6. Because I see the 2, okay? That's not what it's asking, right? There is 1 2 in my option, so it's 1 out of 6. Same thing for 5. There is 1 5 out of my 6 options. Can't reduce. Probability of even. 2 is even. 4 is even. 6 is even. There are 3 even numbers out of my 6 options. That does reduce to 1/2. Probability of prime. Prime means nothing divides into it. 1 is not prime. Okay. 2 is, right, it's a special case. It's the number is only divisible by 1 in itself. Right, so it only has 2 factors. 1 only has 1 factor. It's a weird thing. 1's not prime. 2 is prime, so it's only 1 and 2. 3 is prime, 1 and 3. 4 is not prime, 2 divides into 4. 5 is prime, 1 and 5. 6 is not prime, it also has the factors of 2 and 3. So here, same thing, we have 3 prime numbers out of 6, which is 1/2. Not 4. Here's my, 4. There's 1 of them, so not 4 is 1 minus the 1 out of 6, which is 5 out of 6. Probability of 1 or even. Well, here's a 1. And these are our even numbers, right? So there's 1, 2, 3, 4 of them. Okay. Our last example, going back with compliments, Mr. Carlson surveys his class and finds that 30% of the students have blue eyes. What is the probability that a student doesn't have blue eyes? Well, the probability of blue eyes equals 30%, which is the same, right? We move that decimal place twice, and we get 0.3. So when I'm finding the probability of not blue eyes, that's 1 minus 0.3, which is 0.7, which is move that decimal place twice, 7 in a blank, so 70%. You can also think of it as being out of 100%, and 100% minus 30% is 70%. Okay, but that complement or not, right, we subtract it from the total of 1 or 100%. And that's it. I'll see you guys on Friday after parent-teacher conferences.